Welcome to week 8 of STEP 428. We are officially in the second half of the semester. This week, we're going to keep talking about resampling methods, but with a different focus, which is jackknife. Last week, we introduced one set of resampling methods. In general, resampling methods treat an observed sample as a finite population. Random samples are generated or resampled from the observed sample to estimate population characteristics and make inferences. Resampling methods are often used when the distribution of the target population is not specified. So we do not know something about the target population, where our x's come from, or when the sample is the only information available to us. We introduced the bootstrap last week, which is one method that relies on sampling with replacement from the observed sample. Essentially, the bootstrap tries to use the empirical distribution of the estimator with a statistic applied to the bootstrap samples, which are samples with replacement from the original sample we have, where our x's follow the empirical distribution of our samples. We use this to approximate the true sampling distribution of the statistic applied to a sample of size n, where the x's are drawn from the original distribution f. This week, we're going to introduce another resampling method called the jackknife. The jackknife is another resampling method which is useful for variance and bias estimation in a non-parametric way. The jackknife actually predates the bootstrap. It was first proposed by Kennelly, who was a British statistician in 1949, for estimating the bias of an estimator. So the bias is one characteristic of the sampling distribution. Later on, it was extended by John Tukey in 1958 to the variance, or equivalently, the standard error estimation of an estimator. Tukey also came up with the name jackknife because this way of approximating the variance, standard error, or the bias of an estimator is a rough and ready tool to provide solutions to a set of problems without finding out the specific exact solutions. In the bootstrap paper by Efron, which was written in 1979, he showed that jackknife estimators can be thought of as a first order or a linear approximation for bootstrap estimators. So you can see that these two are actually connected in some ways. If you're interested in this connection and the math stats background of this, you might go to Efron's 1979 paper, where he shows the equivalence of the two under the Bernoulli settings. In this week's lectures, we will cover the jackknife estimators for bias and standard error of an estimator. In addition, we will talk about an application of jackknife, which is the leave one out cross-validation for model selection or variable selection. This is also known as LOOCV. If you're familiar with the machine learning or the statistical learning literature, then this is one of the methods that is very commonly used for model and parameter and variable selection. One thing you might have noticed is that throughout the lectures for this week and last week, we did not discuss much of the theory behind bootstrap and jackknife. So why exactly do they work? What are the asymptotic properties of the derived estimators, etc.? This is because the proofs for these are actually quite involved and require a lot of knowledge and skills beyond 410 or even beyond 510. If you're interested in the theories, these are usually covered in PhD level inference courses, so courses on statistical inference or large sample theory, or if you take a PhD level non-parametric course where they might discuss the proofs behind these.